Okay, so this time we're going to go through partial fractions, and let's sort of explain where these partial fractions, why we actually need to go through it. So, first of all, if we have a look at just a 2009 specialist exam question, one of these questions is asking us to find the area enclosed by the graph of f of x, this thing here. Now, I'm not going to go through the maths behind that. We'll go through that next year. But essentially, what we can do is if we have a graph, we can find the area under this graph using integration. And integration is essentially anti-deriving within a certain range. So in this case, though, the first step is actually involves using partial fractions. So at the moment, we have f of x is equal to and we can't really anti-derive that. There's no real way, especially from year 12, to actually anti-derive that. So the first step is to actually convert it using partial fractions. So first of all, what we would say is 2 plus x squared over 4 minus. Well, first of all, that is equal to 2 plus x squared over, and let's factorize this thing here, 2 minus x, 2 plus x. Now, once we have something like this, what we can do is we can convert this into another form, something that is much, we can actually convert this into two fractions. How do we do this? Well, if we've got 2 plus x squared on 2 minus x, 2 plus x, that actually equals some constant over 2 minus x plus another constant plus x. There's various forms of partial fractions. This is the first one we're going to look at. So the first step of this exam question from the 2009 Year 12 Special exam is to convert into partial fractions. So how do we do that? Well, the next line is, in order to have this all over the fraction, then we need to multiply this side by 2 and the b by 2 minus x. And that's all over this fraction now, 2 plus x. And what we want to do is we want to find these constants. We would need to find what b is. So obviously the left-hand side here is equal to the right-hand side. So essentially what we've got is 2 plus x is equal to a of 2 plus x plus b of 2 minus x. We're not too worried about the denominator for now. What we do now is we substitute, or we just say x equal, we can just say let x equal minus 2 in the first case. What that's going to do is that's going to, we can sub in a known value for x, or the value that we pick, in this example minus 2. And what that's going to do is that's going to cancel this out, and then we're just going to have one unknown. So we can then find what b is. Okay, so the first thing is let's find b, and in this case, b is going to be, so let's say it is equal to 2. So on the left-hand side, we have 2 plus minus 2 all squared is equal to, this is going to be 0. So we're left with b times 2 minus 2, which is plus 2. So 2 plus 2. So we've actually got 4b is equal to 6. So what we've got here is we've actually found what b is. B is equal to 6 over 4, or 2 over 3. Now we have, so we found what b is. Now we have to go and find a. So how do we find a? Well, the easiest thing to do would be this time to let x equal 2. Because that way we've got 2 plus 2 squared on the left-hand side is equal to, this is going to cancel out this, and we're left with a 2 plus 2. So we've got 6 is equal to 4a, and therefore a is equal to 2/3. So we can actually rewrite this original fraction here, f of x, is now equal to, a is 2/3, equal to this, 2/3, 2 plus 2/3, 2 plus x. Now, without going into it too far, this is actually, if we were to look at our formula sheet, to you, but we can actually derive that or anti-derive that using, because it's now in a form that we are familiar with, we can actually anti-derive that to actually become the antiderivative of 1 over 2 minus x, for example. 2 minus x is actually going to be equal to, a log. But we won't get too far into that. The whole process I want you to know is partial fractions is very important for next year, and you will be doing a fair bit of it, and pretty much every exam has a question which you need to use partial fractions to as your first step. So let's have a look at some different categories of partial fractions. First of all, what we've done is there's linear fractions, which we've just done here. I'm not going to go through, we'll go through an example of that, and that's what you'll mainly, but then there's another one where we have linear fractions or linear factors, but there's also a repeated factor. And if there's a repeated factor, then what you need to do is there will be 2 separate fractions. Okay, so this is the same as we just done before, and these two, the repeated factors, we're going to have to find 2 constants. And then finally, there's the reducible fractions, where if we have a fraction on the bottom, partial fractions, then they actually have, you actually need to find a linear factor. So let's, probably a little bit confusing this now, but let's just do a couple of questions and let's show you how to do it. So minus 2. It's important to make it possible. So now the first step of that is to say that because we don't have repeated factors here, we don't need to use the second case, which is up here. We don't need to use this repeated factors thing, or we don't have to use reducible quadratic factors. So we know it's just going to be our linear factors, which is this case here. So what we need to do for that is we now need to say that is equal to some constant plus another constant x plus 2. Okay, so what do we do now then? Then we have to multiply this side here by x plus 2, and for b we have to multiply that by x minus 2. So go ahead and do that. So what we've got essentially is a x plus 2 plus b x and b is. The first thing you would do is we want to actually just let x be something which will then cancel out a. So let's let x is equal to minus 2. And you need to do this. You need to actually say let x is equal to minus 2. So, and therefore, from there, we know that on the left-hand side, it's going to be minus short. minus 2 is equal to in here. So what we're left with is that is equal to minus 4b. So we've got minus 4b is equal to minus 8. So therefore b is equal to 2. Let's let x equal 2, which means that on the left, x minus 2 give us to the left-hand side is going to be equal to, which obviously implies a is equal to 4. So the final step is obviously to write out what our fraction is. X minus 2 over x squared minus. We can now rewrite if that is equal to plus 2 over x plus 2. Now, I'm going to show you now why this is. If we were to anti-derive 4 x minus 2, let me just tell you now that we can actually derive that to be, to be 4 the natural log of x minus 2. So now, by doing partial fractions, we have now got it in a form that we can correctly anti-derive that. We couldn't do that in the format it was. Okay, so let me just pause this video for a while and I'll clear this screen and we'll go to another problem. Now, the problem on the right, you'll notice is not exactly the same as what we've been doing. Here we have a repeated factor. So whenever we have a repeated factor, in other words, we have a square. So x minus 4 squared. And we need to use case 2, which was a linear factor for the x plus 1, and we'll have the repeated factors for x minus 2. So here we've got our repeated factors here. So you'd be using this case here, where if you have a repeated factor, then we have two linear factors here. So let's go ahead and do 2x minus 2 over x plus x minus 2 all squared is equal to a constant over x plus 1 plus another constant. Now, one of the factors of x minus 2 all squared is x minus 2. And the next factor is x minus 2 all squared. So we actually now have 3 due to the fact that this x minus 2 all squared has repeated factors. So from here, we need to multiply. We obviously need to have this. So we need to multiply this x plus 1 by x minus 2 all squared. We need to multiply x minus 2 by x plus 1, x minus 2. And we need to multiply x minus 2 all squared by x plus 1. So let's go ahead and do that. Which leaves basically on the left-hand side, we've got 2x minus 2 is equal to, on the right-hand side, a outside of x minus 2 all squared plus b outside of, that's going to be x plus 1 x minus 2, and I'm running out of room here, but plus c outside of x plus 1. So now we need to solve for A, B, and C. So what we need to do is we need to do a few cases. First of all, the easiest thing to do would be to, I would say, let's find A by letting x equal minus 1. So let x equal minus 1, which therefore gives on the left-hand side minus 4 is equal to, now this is all going to cancel the B and the C, because clearly if we let x equal minus 1, we're going to have 0 times C, and we've got 0 times B. So we've got minus 3 squared is going to be 9 at A. So we've got 9. So therefore A is equal to negative 4 over 9. So we've found what A is. Now let's go ahead and find B and C. So to find C, the easiest thing would be this time to let x equal 2. Cancel this side here out. It's going to cancel this side here out as well. So let's do a second case where we're going to let x equal 2. And from that we know that 2 times 2 is 4, 4 minus 2 is 2. So we're going to have 2 is equal to these two things here. This one here and this one here are both going to cancel out. We're going to have 0 times something. And x is now 2, so 2 plus 3, so is equal to 3c. So therefore, c is equal to 2 over 3. Okay, so we've found those. Now, I guess we know what A is and we know what A is, we know what C is. Now we can go ahead and find B. And in order, I guess what we could do is would probably just make sense now to just let x equal something nice and easy, like 0. We still got to find B. So if we let x equal minus 1, we're not going to be able to find B. If we let x equal 2, we're not going to be able to find B. So let x equal 0, which means on the left-hand side we've got minus 2 is equal to negative 2 squared is 4, and we've got, so that's 4a negative, so that's 1 times, so negative minus 2b and plus c. Now we know what a and c are, so now we can subnet those in. We've got minus 2 is equal to 4a, which is negative 16 over 4, minus 2b, which we don't know yet, plus 2/3. Okay, so that's not minus 16 over 9. It's not minus. Okay, so let's go. 2/3 is the same as 6/9. So we've got minus 16 over 9 plus 6 over 9 is minus 10 over 9. Minus 10 over 9, let's get it over to the other side. So we've got minus 2 plus 10 over 9 is equal to minus 2b. Alright, so let's have a look at what we've got here. So that's negative 18 over 9 plus 10 over 9, which is minus 8 over 9. Let's get that over to, so we've got 8 over 9 is equal to 2b. So 2b is equal to, out of room here, 8 out of 9. B is equal to 8 over 18, or that's going to be equal to 4 over 9. So now we've found A, B, and C. So, sorry, I have run out. But this whole expression here is now equal to A is negative 4 over 9 plus 1 plus, now you certainly won't be as messy, you'll have a lot more room than I have, b is over 9, so it's plus x minus plus c is 2 minus 2. So we do partial fractions to simplify these. Later on when you're doing calculus, you'll need to do that. And so there is a reason behind that. And you can see there that this expression is actually can now be say equal to this thing over here. Okay, so that's using case 1 and 3, which is linear factors, and 1 and 2, which is linear and repeated linear. Now, the only exception is if you ever have in this example here, this case here, it's the same thing, except this time is if you have an irreducible quadratic factor of x squared plus 1, the factor is actually a linear factor of bx. So you need to actually, so just be mindful of when you get a question like this, you need bx plus c in the numerator. So these, just be mindful when you're doing these questions that if you get to this, then please use this bx plus c here. Okay, so have a go at those. I hope that helps, and it's just a matter of practice. But look, let me show you how we would do it here. So this time we have just a linear factor. We don't have a repeated factor. We do have this x squared plus 2, which is we can't. That is equal to the linear factor is going to be because this is an quadratic factor over x squared plus. And the next thing is going to be x plus 1. Okay, so we have that. Let's just let me go to. All right, so it's still recording. Okay, so what we need to do now is we need to have the bottom, these two, we need to multiply ax plus b. We need to multiply that by x plus 1. And this c we need to multiply by x squared plus 2. And so basically that, therefore we can have that part of one fraction. And now we have the left-hand side right-hand side this. So therefore we can just forget about the denominator for the time being. We have 3x squared plus 2x plus 5. I don't know why I keep rubbing the thing out. Okay, is equal to ax plus b x plus 1 plus c x squared plus 2. Okay, so what would we do here? Well, it makes sense to let x be equal to -1 because that way we're going to keep that. So let's do that. So we're going to have 3 minus plus 5 is equal to minus 1 all squared is 1, 1 plus 2, so it's going to be equal to 6. So therefore, we've got c is equal to, so we've got 8 minus 2 is 6. So therefore, 6 is equal to 3c. So c is equal to 2. So we now know what C is, but we need to find what AX and B is. So how do we do that? Well, let's have a work out how we do that. Just let me think for a second. Okay, so I've bit late at night. I can't believe I couldn't actually think of that straight away. But so the next case would be, makes sense, wouldn't it, to just let x equal 0, because that way this ax is not going to equal anything because x is equal to 0, and then we can just solve for b. So if x is equal to 0, then the left hand side is 5 plus b, and then it's b plus 2, and so that's equal to 4. Rearranging that, we've got b equal to 1. What b is, we need to know what a is now. So let's just let x equal anything. Because we're only going to have one unknown, but let's just say let's let x equal 1. Plus 2 is equal to 1a plus b, so that's a plus 1 plus outside of 1, which is 1, so like that, and we can rearrange that, so that would be 6. Take that over, so we've got a is equal to 3. We've now found what a, b, and c. We're not done yet though. Make sure that the end result is that we need to actually what. So we need to wait, so therefore you need to then write this is equal to this thing here, and you have to write obviously therefore that is equal to 3x plus 1 over x squared plus 2 plus 2 over x. Done your different cases of partial fractions. So now please have a go at question from 6C. I think it was questions 1 left hand side, 2 and 3. And for question 6, can you please do the right hand side? You'll need to do a fair few of these to actually get the hang of it. But once you've done a couple, it starts, and you know that there's these cases here. We really exam in week 8.